All right. So programming Monday morning. Let's take a look at it. Let's take a look at the grade screen and see where we're supposed to be this week. Oh, I didn't turn in the math module. I got to write my program. I'll get that done. So, yeah, if you haven't got the math module, get that turned in. We're going to look at the software development lifecycle today. And then we're getting close to next week is the end of module 2. We're going to have a discussion-based assessment, which we'll talk about next week. And then we have a module 2 assignment program to write, which undoubtedly will be something mathematical. If you look at this unit, we've been a lot of math talk. So that's what we'll be writing next week. So had a big math assignment yesterday. We'll have one next week. So let's look at 2.04. We just have a 5-question quiz this week. Software development lifecycle lesson. The programming process. The thing about writing really great programs is that the writing part is only one step in the process. There's a methodical approach that all programmers grow to learn to love, and love to hate. Programmers work to create and solve all kinds of different problems. What they do is different. How they do it remains the same. You know the saying, there's a method to the madness. Well, today we're going to look at the method. So after completing this lesson, we're going to be able to understand the steps, documentation, and tools used in a standard software development lifecycle. We're going to select the appropriate model to use in software development projects. We're going to recognize tasks performed and tools used by programmers to release software updates to customers and understand the need for ongoing program maintenance and methods used to facilitate changes in version control. All right, page 2. The development lifecycle. As you've already realized, programming can get pretty complicated. That's why it's important to have a plan. Code doesn't work. No idea why. The code works. No idea why. Yeah, that's a common feeling among programmers. Sometimes it's like, whoa, that fixed it. How did that fix it? Programmers call their plan the software development lifecycle. This is also sometimes called the application development lifecycle or the software development process. This is basically the fully planned out life of a project, from early ideas and planning to execution and delivery. Without an SDLC, programmers can get stuck wondering why things aren't working. Remember, it's always smart to have a plan. That's why we start putting pseudocode with our program so we can plan out what we're going to do. Here's the steps. A software development lifecycle, known as an SDLC, generally has 5 steps. So let's take a look at each one so we can understand how they help programmers do their jobs better. While the SDLC obviously applies to software, because software development lifecycle, we can actually apply the steps to the development of any project. So for this explanation, we're going to use bicycles. So the software development lifecycle explained with bicycles. Number 1, planning and analysis. The first step is where you define your project goal, create a requirements document, and analyze the scope of work. So with a bicycle, like figure out what a bicycle needs to work. It needs wheels, you need handles to steer it, you need seat, you need gears to turn the wheels, etc. Find out where you can buy all those parts, how long it's going to take to get them, who's going to build it, and where you're going to sell the bike when you're done. Number 2, design. Next, you design your program by writing that pseudocode and mocking up how the software is going to work and what's going to look like. All right, so first I'll do an input statement, and I'll do, calculations. With a bicycle, you sketch out your bike design. 2 wheels, manual pedals, handlebars. Got to include that bell and storage basket. Then step 3 is the coding, where you actually write the code or actually build the bike. Right, we actually do it. Number 4 is testing. This includes identifying any defects and debugging to make sure your software is running in tip-top shapes. If it has inputs, you're entering all kinds of stuff to see if you can break it. With a bicycle, you see if the bicycle actually works. You turn the pedals slowly, you turn the pedals quickly, see if the wheel turns. You get on it, you make a U-turn, you try out the brakes, you make sure the seat's comfy, and don't forget to test the little bell. Ding, ding, ding. Maintenance. This primarily involves updating and making improvements based on user feedback. You put this program out there, and as people use it, they give you feedback, say, hey, the program won't do this, or it gives me an error when I try to do this, or can the program do this? So you make improvements and resolve any defects that arise. With your bicycle, your test users have mentioned that the gears are a little sticky and the brakes aren't totally reliable, and those are big problems. So you tweak the design and you make it a smoother ride. You update the user manuals as needed. So this is the life cycle that we're talking about. See below to learn more about the SDLC, including why it's important, what necessary documentation you need, and why it's crucial for creating successful programs. So step 1, planning and analysis. The planning and analysis step kicks off every SLDC. The team defines the project goals, creates a requirements document that outlines what is needed to build the software. Analysis includes looking into the budget, the timeline, how quickly do we need this program, what resources do you have, what technology do we have already that's existing we can use. In other words, you're going to plan before you do, instead of just jumping in and starting. This will save tons of time and prevent wasted effort. Start building something, and then you figure out your technology won't even run that. Yeah. All right, let's look at design. Rather than jump right into writing the code, programmers use this step to write their pseudocode, just to make sure you got all the steps you're going to need. Helps you think through the whole process and make sure your logic is sound. Because at the end, if you're going to print a total, it's like, oh, I forgot I didn't calculate a total of that. And then you go back into your pseudocode. Oh, that's right. If I'm going to print this, I need to make sure I include this calculation in there. So you go through all the steps in your head. This is also where you provide mock-ups of what the software is going to look like, how it should work. We want the screen to look like this. This is what we want our user to see. They record everything in a program design document for future reference, because other programmers that come along, get hired later, are going to look at this. So they can go back and see the design document and what it was supposed to be doing. Step 3, this is where the magic happens. This is where the programmers actually write code. So once design documents are received, the programmer break the work up into chunks and start writing the program. As the programmer writes the code, he or she includes comments to explain the purpose of each part. You get a long program, you can put a comment, hashtag at the beginning. This is where the calculations are for this, and then so if programs are trying to go back and improve something later, or you're trying to debug something, you know which section to go look at. Testing. Did we mention the test plan? Yeah, there's a test plan. This documents what and when something was tested, how it was resolved, and who tested it. It's like a journal you keep. Testing promptly exterminates all identifiable bugs, but bugs can pop up later. During this step, programmers report all the bugs pronto and fix them to make sure the software runs as expected. You log it in your journal. Mr. Brock, I ran on this date, and I ran into this error, and this is what I did to fix it. Step 5, maintenance. This stage is what makes this process truly a cycle. It involves continued code maintenance, checking for missed bugs that didn't show up originally, but they're in there, making design and functionality improvements based on user feedback, implementation of new requirements. Oh, now we need the program to do this, and user support. The team documents all maintenance-related work in that little journal to ensure the software is operating at optimum levels. Okay, page 3. Software development models. When two people say they love music, they can mean totally different things. One could be a diehard hip-hop fan, while the other's obsessed with that YouTube heartthrobby turned cheesy pop icon, right? Just because you love music doesn't mean you got anything in common with someone else who loves music. These artists do things differently in their live performances, but they both get the job done. They make their fans happy. So the software development life cycles also use different methods to get the job done. Two of the most common methods are known as the waterfall and agile. For some projects and people, one might be better than the other. You got to understand how they work to know which one you want to pick. So let's take a look at the similarities and differences of these two methods. Waterfall method. So with programming task details, the project teams work on one step at a time. All right, let's get all the input, guys. Let's build all this section where we're going to ask the user for input. And we're not going to move on to the next step until the previous step's completed and approved. All right, all the input statements work. We're getting all the information we need. It's all stored in variables. We're good. Now let's move on to the calculation step. Extensive documentation is required to keep everybody on track. Everyone's logging what part they're building. This documentation allows teams to keep control over what version of the project they're working on and what changes are needed and what step of the life cycle they're in. The benefits is this is very clear from beginning to end because you're building it section by section as you go through the program. The drawback is if a change is needed from a previous step, then your process can get seriously delayed. Wait a minute, we've messed up at our input. We forgot this. We need to go back. Then Agile method, project teams do smaller portions of the entire project in small prints. Like your team handles the input. Your team, you be working on the calculations. Hey, you work on the output section. Teams can interact to handle different steps simultaneously if we need it. Hey, we need to make sure the calculations are working with the input team to make sure they're getting all the input they need for these calculations. Documentation is still required to keep everybody on track, and that allows the team to keep control over what version of the project they're working on and how the project's changed along the way. So as an approach to rapid development, this is refers to an approach that puts a larger emphasis on development rather than planning, allowing for the project to evolve and adapt as it's built. The focus is on development rather than planning, enabling teams to start work more quickly. You're not spending as much time making sure you've planned everything out. You get the big picture, and then as you're working through it, you may have to go back and make changes. So, hey, input team, we figured out in calculations we need this value. So you need to go back and build that in your input. And they're working on them at the same time. This process can become confusing at times when people jump back and forth among the steps, right? Because you have to keep going back. It's like, oh, the output people need this. So we need to add that calculation, which means you're going to need to add that input. The methodology choice. The type of methodology you choose depends on the type of project, as does the language. However, some languages lend themselves more readily to rapid development. For instance, certain programming languages like Python or Java have more robust libraries or tools built in that offer programmers more functionality and flexibility. Some languages allow you to easily reuse different parts of your code. Hey, I'm going to use that same function I used up above, making them ideal for rapid development. Why? Because software reuse can save a ton of time. If I don't have to write this section of code every time, and I can write it once and just keep using it over and over again as I go through my program, it saves a lot of time. So while programming languages can aid in rapid development, it's still dependent on completing all the steps in the software development lifecycle. Without proper planning or testing, you can rapidly develop a project, but there's a good chance it'll be full of bugs. All right, page 4. When does it end? Well, actually, it doesn't. That's why it's called a cycle. A cycle, when you get to the end, you go back to it and you start over and over, right? Programmers don't usually ditch projects as soon as they're at the door, right? Think about the apps you have on your phone. The programmers write these apps, but there's constantly new updates. If it's a gaming thing, you got new levels being produced all the time. You got all these updates that happen regularly for quite a while. Once programmers release their software to the public, the major focus is usually ongoing maintenance. Have you ever seen a notification on your phone that an update's available for one of your apps? That's one of the many examples of ongoing maintenance that programmers handle on a regular basis. Why do they do this? Well, here's the two big reasons usually. Bugs. So it's actually not as common as you might think. Unfortunately, it does happen sometimes. Programmers have to be ready to correct any glitches that might occur in their software. Having your favorite app crash on you at the most crucial moment, boy, that's the worst, right? The other thing is enhancements. This accounts for the largest portion of maintenance work. It seems we're never happy with our software like it is. We always want it to be better, so programmers have to come up with new ways to meet our demands. Have you ever thought this game would be perfect if only? Well, send a message to the programmer. You might actually get your wish because they're always making enhancements. Programming trivia. How much was the most expensive bug? Oh, this might surprise you. Let's see. $10 billion. Is that the figure you had in your head? Think bugs are no big deal? Tell that to the northeastern United States. In 2003, a glitch caused multiple power systems to overload data access and caused a total blackout. Programmers had to sift through millions of lines of code to find the bug. Cost upwards of about $10 billion. Caused a blackout. In other words, ongoing maintenance lets programmers update their software so users can continue to enjoy it for a long time to come. Those updates might come through email. You might get a push notification, those little pop-ups you get on your phone, or version upgrades. For the user, it's usually just as simple as pressing an update button when the programmer sends a change. And some updates even happen in the background because they're set to automatically update. You don't even know it happens when the computer's running or your phone or whatever device. Still, for those, you may never even know about it. Two major concerns of programmers in any software development lifecycle are version control, keeping good organization throughout different versions, and change management, keeping documentation about the changes that are needed and made throughout the development lifecycle. Version control is important because a program may go through many, many different iterations in its lifecycle. When a game gets a new level or when your social media app gets a better messaging capability, the programmers must keep track of both the old and the new versions. With this organization, it's much easier to fix problems that might happen during updates. Like Candy Crush, they put out new levels every Wednesday. I knew that because when I used to play Candy Crush, I finished it. I got to the end, there were no new levels, and every Wednesday I would get new levels. I think there was 50 new levels every Wednesday. I quit playing eventually. I got bored of waiting for Wednesdays. Change management means programmers are keeping strong notes about what changes are needed in the future, as well as what changes have been implemented already. This can be important when the team is reviewing what it spends its time working on. Even though every good programming team has a plan that keeps these things in mind, it might not carry out the plans in the same way. There's many methods for implementing the software development lifecycle, and teams have to choose the development method that works best for them. So that is the end of the lesson. Let's look at the quiz that goes with it. What is the waterfall method? So, we studied that. Kiara is using the software development lifecycle to create a new app. She's created an outline of her program, including pseudocode and a mock-up of how it should work. What stage is she ready for next? Creating a songwriting app. She's debugged it. What should she do next? What is change management? True or false question. All right, 5 questions. That's all you got this week. So if you're still catching up with some programs, this is a good week to do it because this is a very short lesson this week, just the 5 questions and all that good stuff. So I know some of you aren't finished with the last week's program, and I apologize. I still haven't got the video uploaded because it was a short week and I got too overloaded with everything else. But I will have that this morning from last week if you need that. So that's all we got. It's a pretty short lesson this week. It's only 7:36. So you got time to get this quiz done and get ready for next class. So you got plenty of time there, guys. So if you want to hang around, if you got any questions, I'm happy to take them. Otherwise, you guys can go and probably have this done in no time. So have a great week. Oh, it's an A-Day Friday. A-Day Friday.